Hello, everyone.
Hi.
How's it going?
Good.
Okay. So, the slippers are over there. I'm just in my socks for now.
Yeah.
So, my
It's his uniform.
My clicker's disconnected. That's a good sign.
Oh, okay.
I can pick it up from now, actually. So, earlier this year, a few of us went on a fact-finding mission to India to see how folks here use the internet. And one thing stood out to us, and that is that feature phones are back.
Yep, the feature phone market doubled in 2018 in India, and the sale of the smartphone flattened. At current rates, 400 million feature phones will be sold in India this year.
Yes, and whoever's controlling the speaker, if you could make the music stop coming out of it, because I feel like I'm on a really weird music video right now. Thank you, that's good. Okay, so these phones, they're pretty different from smartphones, right?
Yep. The Geo phone, for instance, is 240 pixel wide display, single density, no touch screen. The processor is awful, but they're relatively cheap, right? We all know that Geo phone is very cheap, and it's getting millions of people online for the first time who couldn't afford it before.
Yes, also the Geo phone is a web-based phone. It's running KaiOS, which is a fork of Firefox OS. So it's running, well, Firefox 48. We've seen some running 42, 48. It kind of depends
like 39,
on how
yeah, but the newest, I think KaiOS 2.5 is running Firefox 48. And a lot of companies in India here produced a web apps for these phones, such as Z5, but we wanted to see by ourselves how far we could push these tiny devices.
Yeah, I'm going to see if I can get my clicker working again. Here we go. Oh, no. Well, do you know what? That's good redundancy that we have two clickers, because you can take over. So yes, a little team of us got together consisting of Mariko.
Yep, and Jake, and
Sama.
He's in England.
Yeah, he's in England. England's that way. I think we worked it out.
Probably. Maybe that way. I don't know.
If you go far enough. I think you could go both ways. It's shorter that way.
Yeah. So we wanted to see if we build an interactive web experience that would run on devices like this, but with responsive design and progressive enhancement, scale up to something that looked great on desktop. Right,
I think I'm going now. So that thing became Prox. Did you press that or did I press that?
Yes, I did.
Okay, fair enough. You can continue doing that. So Prox is a game, and if you like Minesweeper, you'll like Prox because it's the same.
Yeah, so here it is on the desktop. How many of you have seen Prox before? Oh, great. Hi, users. Great. Cool. So we've shown a lot of animation and stuff at it, but it's scaled down nicely and display and playable on feature phone using same code base. We only have one code base.
Yeah, we put in a lot of effort to make it fast, so we figured we'd go through the tricks and techniques that we used, because none of this is really unique to games, none of it's really unique to this particular app. It's stuff that you can do on any web app or website.
Yep, but before we dive in, let's tackle the question that crops up on the Twitter a lot.
Yes. Should I care about performance?
Should I care about performance?
Should I care about performance? We think yes. We think that's the right answer. Yeah. Our go-to article for this is this one on Web Fundamentals. You can find it at this bit.ly link here. It points to web performance studies carried out by a variety of companies.
Yep, so such as Pinterest, who reduced the perceived wait time by 40% and saw 15% increase in signups.
Yes, or Cook, who reduced their load time by 850 milliseconds and saw an increased conversions in session time.
Or the BBC, who lost additional 10% of users every additional second the page to load.
Or AutoAnything, who reduced their page load time by half and saw a 12% boost in sales.
Or DoubleClick, who found publishers with the sites was loaded with 5 seconds aimed at bad.
You nailed that in rehearsal. That was close. Of course, terms and conditions apply. Although that's a large variety of sites, we've seen folks that say it doesn't apply to them because their site is somehow different.
Yeah, their site doesn't exactly match what we see on the case studies. Therefore, they don't think it's evident that it doesn't apply to them. Yes. We don't buy that.
No, I think everyone in this room is a user of software, right? And we all know how frustrating it is when something performs badly, and load time is a huge part of that.
Right. So the performance optimization we're going to look at today are pretty simple.
Dead easy.
Literally 2 minutes.
On paper. But when you've got a build system wrapped around your project, sometimes adding an extra tag can be a real pain. So we're going to look at that side of things as well.
Yep. Let's rewind the first version, the alpha version of Prox, before we done any optimization.
Yeah, this is totally the original alpha version, not just one we've invented for this talk. Okay, I'm sorry.
Yeah, you're ruining the illusion. Aside from being a bit slow, it wasn't all that different from your average JavaScript-driven applications.
No, so our HTML file, it looked a bit like this. This might be familiar to you in a few projects. It's pretty basic, just a bit of metadata. The JavaScript include there, that takes care of populating the page. We've got a style sheet there, but that is just for a web font. The rest of our CSS is embedded in our JavaScript via PostCSS.
Mm-hmm. So the notable difference from the most web apps is that we use Preact instead of React. So React is 33 kilobyte in total. Preact is 3 kilobyte. We didn't need any of the additional features that React provides, so it was no-brainer that we use Preact. 30K kilobytes saved for free.
Yes, the other difference is that we used Rollup. Basically, we wanted to give Rollup a try, but we've used Rollup for libraries before, but not for full web apps.
Yeah, so we see last year, we built another web app called Scoosh. And to build Scoosh, we used Webpack. And we say we, it's really just our colleague Jason handle the Webpack side of things.
Yeah, Jason's in America. We think America's that way as
well?
Yeah,
I mean, England is that way. If you
and
go
you just
over
keep
England,
going,
yeah.
And that's America, okay.
Yeah. He had to make use of a lot of undocumented Webpack internals just to do basic stuff. He has years of Webpack experience and no inside out, but we don't.
Yeah, so as a result, we didn't really understand the project's build system, and if anything went wrong, we were kind of just waiting for Jason to wake up so he could help us with it.
Yeah, and talking to other teams, we hear same stories, like maybe 1 or 2 Webpack whisperers set up all of the build system, and no one else really understand how it's made. And maybe this sounds familiar to you.
Yes, so when I use Webpack, I don't feel like I'm using JavaScript. I feel like I'm flipping switches in like a massive config objects and like herding lots of plugins of varying quality that often don't really play well together.
Yeah, so we thought we'd give Rollup a shot. We found lots of plugins that are varying quality that often don't play well together.
But, and this is the key difference, mere mortals like you and me can write our own plugins. Like Rollup has a simple, well-documented plugin system. It's really easy to get involved in the innards of the build. Like seriously, if you know enough JavaScript to wrangle a Webpack config, you know more than enough to write a Rollup plugin.
Yep. Also, because we knew we were going to have a tough time using, the application runs a lot of animation and things, so we knew that it's going to be tough time running everything on a single thread for these feature phones. So workers, the web workers, were a core part of our architecture from the very start.
Yeah, we use a little library called comlink to facilitate communication between the main thread and the various workers that we used. So that library is needed in both places. Well, it's needed on the main thread and it's needed in every worker as well. This is a little library that Surma built. It makes it really easy to communicate with workers. Unfortunately, Webpack cannot share chunks between workers and the main thread, so the user would end up downloading the comlink code, well, at least twice, once for the main thread and then once for every worker.
Yep, and this could happen on each shared dependency, not just comlink. So Rollup handled this out of the box, leaving choice of the format for developers like us.
But it wasn't just JavaScript that we needed to handle. We needed HTML as well.
Yeah, so there's a Webpack plugin to help create HTML for your project. But here's a code for that plugin. It's massive. It relies on a lot of undocumented parts of the Webpack.
Yes, this plugin is so big that it actually has its own plugin ecosystem. It doesn't really want you touching the HTML itself. Instead, you have to learn its configuration objects and all of their quirks. Your skills in HTML are not really useful here.
Yeah, we couldn't find a good equivalent for Rollup, so we decided to write our own. Rollup plugins are functions that return objects. The objects have a name key, just so that Rollup can provide better debugging information when something goes wrong. The rest of this object is callback for various stages of the build, and they're all documented.
Yes, so the callback we're going to use is generate bundle. So generate bundle gives you these couple of arguments here. The first one is the options that Rollup was called with, the output options. But it also gives you this bundle object, and this bundle object is amazing. So we'll take a look at that. It tells you everything about everything about the build, like all of the bits and pieces for it.
Yeah, so for JavaScript files, you get the code, the initial path, the file name, which has been hashed to make easier to cache, but also loads of data about the dependency of the file has and everything it exports. For non-JavaScript assets, you get less information, but still get access to that data.
Yes, indeed. So now we can create our HTML. So what we're going to do is we're going to load a template. This is just an EJS template we decided to use. We just picked EJS. It's what we wanted to use. Rollup doesn't care what templating language you use as long as it returns a string. And once we've got the string of the HTML we want to use, we then use this emits file method, and we say this is an asset, here's the file name, and here's the source code for it. And now Rollup will write that file along with everything else.
Right. So here's our template. We've got a placeholder here for the JavaScript URL. We don't know what it is right now because that's Rollup that's going to add the hash to it. We need to pass the URL of the JS after hashing. And we can get this from the bundle object. Since it tells us the both input and output, we've created a little helper here for the get.js. This searches the bundle for the correct entry.
Absolutely. So now all we need to do is add that plugin to our set of Rollup plugins there, and that's it, we're done. Now you know everything you need to know to write a Rollup plugin.
Yep. I realized that this was a lot of words that we just threw at you, but compare it to the Webpack version, we'd argue that the one we wrote was much simpler.
Just a little bit.
Yeah, just a little bit.
Simpler.
Everybody in your team should be able to understand and adjust it.
Yes, and even better, like we're writing code to do what we want rather than wrangling config. Like if we want our HTML to build slightly differently, if we want those tags in a different order, we just go in and change the code, change the HTML code.
Yep.
But what do we actually need to change?
Yeah, so we needed to find out where Prox was losing performance. Our tool of choice for testing these situations in somewhat real-world situation is our Webpagetest.org. It lets you test on the real devices and with excellent throttling.
Yes, we're going to be testing on a Moto G4. This is a fairly old mid-range phone, but not dissimilar to the kind of devices people are using all around the world. We're also going to test on a 3G connection.
Yep, so 3G is good speed to measure because some of the time you will have 4G, but due to signals or conditions, you'll be experiencing speed more like 3G or worse.
Yes, so here are the results for the very first version of Prox, the one that wasn't optimized. The first thing I tend to look at is the Filmstrip Strip here along the top, because this shows what the user is seeing as the app is downloading.
Yep, so let's break this down. For the first 4.2 seconds, the user sees nothing.
That's what nothing looks like.
Yeah, quite literally nothing.
Yeah, totally thingless.
Yeah, so, but out of the nothing, here comes our first render.
Yeah, this is the first render, but we can't really count this as ready until the user sees something more like this with the full UI and interactivity. And the user doesn't actually get that until they have been waiting for a whole 5.1 seconds, so that's not so good.
Yeah, no. But it was, like we said, we're targeting these feature phones. So, and of course, like, internet speed in India, much closer to 2G, right? And then, like, especially in rural areas where these feature phones are popular. So on 2G, the user gets 8.1 seconds of nothing. Then, like a pretty useless render, are almost 11 seconds until they're able to play the game.
Yeah, 11 seconds. Let's put that into context. Usain Bolt can run 100 meters quicker than it takes to road a dumb game over 2G. You know, that's terrible.
Yeah, so the user had to download 64 kilobytes before the site was interactive. Surely we can do better. But how much better? I asked Jake to figure that out.
Yes, so I did a little bit of competitor analysis on this. So this is a graph that shows the size of Windows Minesweeper over time. So it started out as 11K in Windows 3.11, and then it actually got smaller in Windows 95. I think that's actually pretty incredible. So it's only 9.63 kilobytes. That's amazing. That's much smaller than Prox, the piece of shit app we made. But then in Windows 2000, whoop, look what happens there. Jumps up in size, doesn't it? It becomes 7 times bigger, 70K. Now it's bigger than Prox at this point. And the size crept up again in XP as well, up to sort of 80K. But then, bam, it became 50 times bigger. That's 3.84 megabytes in Vista. And it's sort of roughly the same there in Windows 7. But then, bam, it became 25 times bigger still. This is 104 megabytes in Windows 10. That's unbelievable. Minesweeper is actually growing so fast here. To make sense of the graph, we have to switch it to a logarithmic scale.
Yeah, so if we... So if you wake up at night worrying about how much your CSS file is growing in size, this is way worse.
Yeah, we've actually been analyzing this trend and seeing where it might go in the future, and we predict by 2025, Minesweeper will be 2 terabytes in size. By 2030, 2/3 of the planet's surface will be covered by a single hard drive containing 1 copy of Windows Minesweeper.
Yes, so Greta and activists are doing great towards spreading awareness of climate change, but surely the biggest threat to the mankind is Windows Minesweeper.
Yes, absolutely. So in conclusion, prox 62K, we're not doing that bad, really.
Yeah, thanks,
so
Jake.
Thank you and good night.
Yep, truly great report.
Thank you.
We know Minesweeper can be done in 10 kilobyte, right? The Minesweeper started in 10 kilobyte. Our version has a little more going on, like graphically, we have animation, but still, it's 62 kilobyte to interactive. We should probably reduce that.
Yes, we probably should. So if you want to improve the performance of your site, but you only have a few minutes, identify the important resources that start downloading a little bit too late. So looking at the timeline here, we're getting to render at 4.2 seconds. But our JavaScript is fully loaded at this point, so the site is ready to go, but it is useless because there is no text here.
Yeah, because, we're using web fonts. We're using Space Mono from Google Fonts, both the normal version and the bold version. They are both 10 kilobyte each, which isn't all that bad. So why is it, giving us trouble?
Yes, to find that out, we are going to take a deep dive into the network waterfall in Webpagetest, which is very similar to what you'll get in Chrome DevTools as well. And this is the pattern we were seeing. First up, HTML downloads. Yeah,
the thinner line here is convention both Webpagetest and DevTools uses. It means that it's setting up HTTP connection. And the thicker one here represents that it is a request and response time.
Yes, and once the HTML is downloaded, we then download the CSS and we download the fonts as well. It's worth noticing when you're comparing things like a network waterfall to like rendering on the page, they don't add up perfectly, they don't align perfectly because once the browser has downloaded the fonts, it needs to parse them, it needs to process them, and then it sends it off for painting, and then finally it'll appear on the screen. So you might see like a couple of 100 milliseconds delay between those two things happening.
Yeah, but the red flag here is the CSS and the fonts both have these thinner lines, meaning they are setting up connections. This is because the CSS is on another server, fonts.googleapis.com, so it has to start new connection for new domain.
And however, if we look inside the CSS as well, we can see the fonts, they come from yet another server, fonts.gstatic.com, so that's yet another connection.
So a quick fix here is to copy the CSS and the font onto our own server. Then the way it can reuse the existing collection for the index.html, and in theory, that should improve things by a second.
Wait, you can't just do that. Fonts are protected by various intellectual property laws, including trademarks, copyrights, and design patents. Copying them to your server may violate the policy of the rights holder.
But whilst that is maybe true for many font providers, it doesn't apply to Google Fonts. So you're allowed to host them on your CSS and on your servers.
Ooh, disaster averted. I, for one, will be able to sleep at night.
Yes, great. So in fact, the CSS is so small, we may as well just inline it in our HTML.
But what about these fonts, right? The browser tries to be smart when it comes to font downloading. It won't download the fonts until it finds something on the page that actually needs them. And that means it has to wait for the CSS to download, and it has to wait for an element to appear on the page that contains text that needs that font. And this is good in some ways because it means the browser can avoid downloading fonts that it doesn't actually need on the page. But in this case, we know it needs those fonts.
Yes. So the answer here is link rel preload tags in the header of the document. This tells the browser to download that font file, the particular thing that you want to use, and then hold it in memory until it's needed. And with those small changes, we should see this yellow line shrink when we next pass it through the Webpagetest. Well, at least that's the theory anyway.
But we have to get this working with our build tools. So here's the Create HTML plugin that we created earlier. What we're trying to do here is we're going to inline CSS for the fonts and add a preload tag for each of them. I'm not going to go through it step by step because we only have 40 minutes here, but it looks a little like this. Whoop. there it goes.
Yeah.
Just a few extra lines.
Yeah. At the start of the build, we use the Rollups emit asset method to bring our fonts into our build. And then this means Rollup will handle that file name hashing for us. Then when it comes to generate our HTML in this plugin, we pass that data into our template. So where this helper gives us the final URL for the font.
Exactly. So now we can use this data in our template. So what I'm going to do here is iterate through the font data that we put into the template, and we're going to output a style tag that defines the font, and that's just using the data that we passed in via the plugin. And then what we're going to do is just output a little preload tag for each one, I guess.
Yeah. And then?
So there it goes. There's our preload tag. Yeah, there it goes.
Right.
Easy
so
peasy.
What I like about this is that Rollup plugin is handling the stuff that's specific to the Rollup, like hashing the files, getting their name. For the HTML part, the one that we know, you are writing HTML, not the Rollup specific HTML, right? Rollup isn't preventing us from rearranging the tags or adding new tags.
Yes, but we are not done yet. Fonts aren't the only asset that's loading too late. At the same time, we download our script. It also downloads other scripts that it depends on. This is because of the code splitting that we explained earlier between the main thread and the various workers. However, a bit like the fonts, we know that the main page always needs all three of these scripts, so we should preload those as well.
Yeah, but how can we figure out which script to preload, right? Rollup's bundle object gives this answer. Remember, it gives a lot of information to us developers. So for each bit of output.js, it gives us an array of files it directly imports. So we pass this property into our template and back over in our EJS template. And we can loop over those dependencies and output preload tags.
Yep, just like that. So we've moved the fonts onto our own server, and we've added some preload tags to them and to our scripts as well. This is all better in theory, but what does Webpagetest actually tell us about the real-world impact?
Yeah, let's look at it. So we've eliminated the no fonts render. As soon as it renders, everything else is ready to go. That's 1 second improvement on 3G and a massive 3 seconds improvement on 2G. So we haven't really impacted the red bar though. That's the part where the users see absolutely nothing.
Yeah, and 4 seconds, that's a lot of nothing on 2G. It's 8 seconds. That's a lot of nothing. And this is the part of the loading process where the user doesn't even know if the server's responding. They don't know if they're ever going to get an answer from the server.
Right. So looking at Webpagetest network waterfall confirms that we achieved what we set out to do. Everything important is loading in parallel, right? But it's just taking too long.
Yeah, so we have two options here. Like, we could try and just make these bars shorter by reducing the code, or we could just make it matter less.
Yeah. So right now, we are fully reliant on JavaScript for our first render. Let's put a stop to that, and let's do server-side rendering, but like in the build time. So we call it the pre-render or static render.
Yeah, we want the user to see something like this. It isn't interactive at this stage, so we've removed any of the buttons that require JavaScript. But this can appear while the JavaScript's downloading, and it improves the perception of performance because the user sees that something is happening. And then once the JavaScript loads, it can enhance the page just like this.
Yeah, there are a few ways to do this. Every DOM orchestration framework that's worth using have some kind of way to generate HTML from a component. In Preact and React, it's render to string. This is pretty fast. Not as fast as other template languages, but it's fast enough that large-scale sites run it on every request sometimes. Although we were only generating HTML at the build time, so performance isn't something we were too much caring about. However, it runs in Node, and we actually see that as a downside. See, if you have any code that assumes it's running in browser, for example, you may be accessing IndexedDB, it's going to fall down from here. To fix it, you'll have to end up with a lot of code branching. Still, render to string is probably the ideal if your code base can adapt the rest of the code for it to kind of make it nicer, but it's not what we ended up using.
No, we looked at JS DOM, which is like a kind of browser that runs within Node. The problem there is the word kinda. It's like a completely different browser that you have to support. So we tried to use it. This is what we were intending on using. But we found these sort of weird behaviors. One weird behavior, it kept on losing some inline background images we had set on some elements. And we dug into why, and it turns out that JSDOM doesn't understand linear gradients. And as per the web specifications, browsers ignore inline styles that they don't understand, and JSDOM was behaving like a browser, but a browser that doesn't understand linear gradients. Also, for what it's worth, it's slower than render to string, so it isn't something you would often want to be running on every request.
Yeah, so in the end, we went with Puppeteer. Puppeteer launches a headless version of Chrome. So you can load pages, execute JavaScript, and then read that result out of that. Your code is running on the actual Chrome, so it's not like you're supporting new browser. But however, it's slower than render to string. A little slower than JSDOM, but not that by much. We only need to run it once per build, so for us, it wasn't a big deal. It's really easy to install and use, but adding a whole version of Chrome to your build is a pretty big jump in complexity. It's what we ended up with procs, and it wasn't too bad, honestly.
No, it was okay. So how did we actually get it working? Well, we wrote another plugin, didn't we? There it is. I'm not going to go through it line by line, but just wanted to show you that it's a relatively small chunk of code. Like Puppeteer lets us launch this invisible version of Chrome, run our JavaScript, and then we can collect the HTML that it generates from all the DOM elements. We can just serialize those. Also, since our CSS was in our JavaScript, it created style tags for all of the components that were used in that first render. So we've collected those up as well. I mean, we kind of got CSS inlining for free.
Yeah. So one bit we haven't covered is how do we prevent the pre-render from rendering elements that aren't interactive. What we want is something like this, right?
Yes, absolutely. The simplest solution to achieve this is to give a little bit of code like this to Puppeteer, and that can run before the rest of our script. And that means in our app, we can branch on that, and we can do something different, such as hiding buttons. And since this is only true in Puppeteer, it's not going to run those steps for real users.
Yeah, but it means you're shipping pre-render code to the user, code that they don't need. And it's probably not a lot of code, but it's probably not worth putting the effort into shipping it?
Yeah, we probably actually don't need to worry about this. I think it's fine. It's fine, just a little bit of code.
You're still shipping the extra code. Shall we fix this?
Yeah, go on, let's fix it anyway.
Yeah,
come on.
Good. So our aim is to remove this code from the build that reaches the user, right? This code only needs at the pre-render build process. So here is our current set of plugins. Can you guess what we are going to do now?
I have literally no idea.
Well, we're going to write another plugin.
Yes, another plugin. Brilliant.
The plugin means that we can write a code like this, and the value of pre-render here. So will be whatever we pass into, right, the pre-render, and our build script.
Yes, a plugin like this, I use this on a lot of projects now. It's really good for lots of kind of constants, like version numbers, flags, booleans like this. I've seen similar plugins that don't require the import statement like we've used here. They just change some JavaScript value throughout your code. And I kind of hate that. I don't like that because it's not obvious to the reader of the code that some build magic is going to happen there. Whereas here, I see this, and I see this is a special import. This is some kind of magic import. It's not a valid URL. So something special is happening in the build system. I can search for that code, and I will find the Rollup plugin that's actually handling it. And also, Rollup is actually really smart here. So if we do a build where preload is true, what Rollup will do is it will actually optimize this bit away, so it is just the block there. But more interestingly, if we do a build where it's false, it will optimize this to this.
Yep, that's what we did. We created two builds, one for users and one for Puppeteer. So let's take a look. This is the entire plugin. The plugin only does something when the import starts with const. And if it finds such an import, it generates a code containing the default export on the fly. That's it. That's all.
Yes, I use this plugin everywhere. OK, so here's the comparable Webpack plugin to do the same thing, if you want to benefit from the dead code elimination side of things as well. Again, this is not something that I would feel comfortable hacking around in. Now, you might feel that we are giving Webpack a bit of a beating here. and it's because we kind of are, but like, the honest truth is that the difference between working on a project with Webpack and working on a project with Rollup has been night and day for us. Like, with Rollup, not only did we feel that we understood what was happening, but we felt capable of changing what was happening if we needed to.
Yeah, especially with less trodden paths, like making workers on the integral part of our architecture, it was invaluable.
Yes, absolutely. So now we have this optimized server render. What do we win? What is the real world impact? Well, here we go. We've pushed that red nothing render time right back. We've cut almost 2 seconds of white screen on 3G, 3 seconds on 2G. This is a massive improvement to the perception of performance.
Yeah, so the yellow area represents time that we've rendered, but app isn't yet interactive because the JS hasn't loaded. But at least the user is seeing some progress on the screen. It's not the white page. So what's next? Looking at the network waterfall, the thin block at the start of the connection setup is the setup, and the thick block is everything between the request starting to the final byte of the responsive being received.
Yes, and there's another feature that we can look at here that's a feature that's also in a Webpagetest and also Chrome DevTools. We can look at the time to first byte, and this is how it tends to represent it. This is the time taken up by the request and waiting for the server to start sending the response.
Yeah, as you can see, there's a pretty big gap between the receiving the HTML and getting the first byte of those important assets. It's about 400 milliseconds on 3G and a second on 2G.
Yeah, there are two solutions to this. Number one is HTTP2 server push.
No. H2 push is incredibly hard to get right. We've seen teams of a good number of experts try to use it, and they barely break even on the performance side.
Okay, so that leaves the alternative, which is inlining. We take these assets and we put them straight into our HTML.
Yep, so first up, our fonts. So inlining both our fonts would add at least 20 kilobyte. Remember, each bold and the normal is 10 kilobyte each to our HTML, which is kind of a lot.
Yeah, so I took a look inside these fonts, and I found some interesting stuff here, I think. 3/4, upside down question mark, surprised face. Once again, don't know what that is. This is for cases where you need a P and a B at the same time. We've all been there. And this one, this is like, I don't know, this looks like a sort of elephant that's sitting, something like that. Does that make sense?
Yeah? It's fine. So the point is, none of these characters are in this set, the set of characters that we are using on this opening screen, right? All of the characters. So we figured we'd just inline that. It's kind of like a tree shaking for the code. In the font, people call it subsetting. There are command line tools for this, but most of those font tools use Python, and I don't really like Python.
What's wrong with Python?
That's fine, it's fine. I don't really like them. There's a little known feature in Google Fonts. The URL for the font CSS can include a text param.
I like Python.
No, the Google Fonts can do this. Like, you don't need Python.
Okay.
If you include a text param, the fonts in the style sheet will be subsetted. Just include those character Jake for those subsetted characters. So we used that to subset our fonts, and then went into the style sheet to download the result.
Yes, and then we use our build script to open these files and split them into the template as base 64 URLs. And this added only 4.5K to the HTML, like much less than the 20K for the full fonts. Now we still load the full fonts. We load them lazily in the background because we need them for future parts of the game, like the main part of the game, the end screen, things like that. But we don't need them for that very first render.
Right. So let's look at how we do this. Here's our create HTML plugin that we looked at earlier, or at least the part that feeds the data into the template. So for each font, we are passing in the weight and URL, but we are also going to pass in the inline font as a base 64 encoded string.
Yeah, and this bit is just using built-in Node APIs, right? But we're also going to pass in the character sets. This is for the Unicode range for each font. If you've dealt with web fonts before, you'll have seen that you can specify this in Unicode range, and that tells the browser what's inside the font and lets it optimize some of the loading that it can do. We use this library from NPM, character set. You can just give it a load of characters, and it will figure out the most optimal Unicode range for that. It's really handy.
Yep. So now that we are passing everything into the template that we need inline the font, but what about JavaScript?
What about JavaScript? So here's where we're getting the file name for the main JavaScript that we're passing into our template, but Rollup will also give us the code. That's part of the bundle object as well, so we can just change that. Job done. There we go. And we're also passing in the file names here for all of the dependencies. That's how we were creating the preload tags before. So instead of this, what we're going to do is go and find the actual code for each of those using a map and get the code for each of those, and there we go. So we actually had to change the template as a result of this, but again, this is using our skills in HTML, like nothing plugin specific. So here's where we're doing the inline fonts. You can see it's part of a base64 URL, the Unicode range there, and here's where we're outputting the inline JavaScript there as well.
Yeah, done, in theory. But how does it impact real-world performance, right? We've already improved things by a lot, but with inlining, we've reduced our interactive time by ½ a second on 3G and a second on 2G.
But we are not done yet. Now that the JavaScript is inlined as well, we've reached a point where we only have to look at our index.html file, because that contains everything that's needed to get to interactivity. Like, we've come a long way. Even over 2G, we are now interactive in under 6 seconds. Pretty good. But I think we can do better.
Yeah, our index.html is 43 kilobyte right now. Out of that, 32 kilobyte is JS. But that's the code for everything. Right? All the fancy animations, the WebGL, the end screen, but the user doesn't really need anything yet.
Yes, what we've done here is we've done the Photoshop thing. I'm sure you've experienced this before, where you end up staring at this screen for sometimes minutes while it loads 100 plugins, 200 plugins, loads of plugins. And the weird thing about this is the only thing you can do in Photoshop once it loads is open an image or create a new one. You don't need all of these plugins yet.
Yeah, so this is my favorite plugin. Highlighted the bottleneck? I can't even pronounce it.
Yeah, when you showed me this image, I thought you'd just made this up. Like, this is a real plugin?
No, it's literally in the Photoshop. Yeah,
okay,
plugin, yeah.
Excellent. I don't know how to pronounce it either. I think it's Highlighted bottlenecks, which sounds like a Swedish folk singer, but I don't know what it does.
So let's not load everything before the user needs to use that. Let's prioritize the code. So to do this, right? The first interaction in this code, like this game, is to pick the level of the game you want to play, and that's all. Like, we need to be able to react to that user hitting the start button, but not necessarily starting the game. Like, if user manages to hit the start button before JavaScript downloaded to do the produce the game, then we just show the loading screen. Everything else can load somewhat lazy. It doesn't matter if it's seconds later.
Okay, so we need to code split right at this point. Code splitting in Rollup works very similar to how it works in Webpack and Parcel. Like, imports like this will cause whatever.js to become part of the main bundle. If you want it to be code split, you need to turn it into a dynamic import instead. Now, this gives you a promise, so if you want to actually use the module, you will need to await it. This means now that whatever.js, it won't be bundled, it will be put into another chunk.
Yeah, so it makes it async, which can create its own problems. For example, component frameworks expect rendering to be synchronous, right? React Suspense allows to load a component lazy, but Preact, remember we're using Preact, doesn't support the suspense yet. So of course, we wrote a plugin. It's like 20 lines, seriously. It doesn't do half of what React Suspense does, but it does exactly what we need for this project in 20 lines. It wraps a promise of a component and gives us an actual component. You can then use that component to render a placeholder. So provided by the function passed to this loading attribute, sorry. Until the Nebula component loads, we just render the placeholder of a div. But once the Nebula component is ready to use, the other function will be rendered, which gets passed freshly loaded components.
Yeah, and that was everything we needed. And with that, we've moved all of our components to a lazy model, except the ones that we needed for the first render. And this cut off over 20K of the HTML. The JavaScript is now down to 11K. And I mean, when you think about it, the start of our game is just like a form, really. So 11K is quite a lot. But we were pretty happy with that. We thought that was enough. But how do we ensure that this doesn't creep up over time?
Yeah, so it's surprisingly hard. Like, you write a new component, you do everything right, you load stuff lazily, none of your colleague is looking, and you're having a weak moment. And then you do it, you use VS Code autocomplete. And boom, you have that static import. If the component is used in the critical rendering pass, you might have just added a whole bunch of inline code into this bundle. This is how Microsoft Minesweeper happens, and we want to prevent that.
Yeah, so we tried a couple of ways to do this. We had a comment like this, like, warning, this is part of the main bundle, please, like, don't touch it, because everyone reads the documentation, right? This was it's a reasonable effort, but tools not rules. So we wrote a little thing that we could hook up to Travis CI, and what this does is when it builds something, it logs out all of the files of everything in the build directory. But that means that on the next PR, it can go into the logs of Travis, and it can see what the sizes of the previous build were, and it means it can output the delta. So that means that per PR, we can go and look at this, and we can see that if the index.html file has suddenly grown more than we expect, and if this file is getting suddenly bigger, that suggests that something has gone wrong with the bundling in a way we didn't expect, and we can go and investigate that before shipping it.
Yeah, it was quite handy. So, what did we win? What does that gain us, right? Since this was our last optimization, let's start from the top.
Yes, we started 5 seconds until ready on 3G, 11 seconds on 2G. What we did now is we moved the fonts onto our own server and preloaded the fonts and the scripts, and that improved the time to interactive.
Yeah, and then we added a static renderer, improving perceived performance by getting the pixel on screen early.
Yes, and then we inlined the scripts and subsetted the fonts, bringing down the time to interactive again.
Yeah, and then we split the code, right? So we prioritized what we needed for the initial interactivity. And then slashes the time to interactive by over a second on 3G and 2 seconds on 2G.
So from our starting point here, we've halved the time to interactive. Let's actually feel the difference that we've made. So on the left here is our original alpha version without the optimizations, and on the right, our latest version loading over a 2G connection. And off it goes. So we can see this is the initial connection phase, nothing we can do about that. And then bam, on 2G, it's interactive now, the user can use it. Still white screen here, this is useless, no text, and then sometime later, it's finally interactive.
Yeah.
That's what that feels like.
Yeah, so remember, when you're on the festival or train or using conference Wi-Fi like today, or just on vacation, you will be experiencing speed closer to 3G or even like 2G.
Yes, absolutely. And once they're playing the game, I'm not allowed to ship anything without using a service worker, so I added a service worker. It works offline, and that also means that the second load is instant.
Yep. So where did we end up with our plugin counter, Jake?
Well, let's find out.
Well, to be honest, we wrote way more plugins for this project than what we talked about today. Here are all the plugins that's currently in our rollup config, and I think it's faster to show which one we didn't write. So in total, that brings us to 16 plugins.
Yay. Now, is that a bad thing? I'm not sure. I mean, I prefer wrangling code than I do wrangling config of other people's code. I think it's really empowering to be able to go in and fix stuff without spending days learning a new DSL or anything like that. And I want to make it clear, we're not saying that you should go and use our plugins, because they're kind of dependent to procs, and they're all sort of interdependent as well. What we're saying is, write your own. Sometimes it is a lot quicker to write code to do the thing you want to do rather than take something off the shelf and try and bend it into the shape that you need it.
Yeah, and remember, we care about users, right? So if your current build tools are stopping you from making simple changes like editing HTML to help that users get a better build tools. Right?
Yep. Thank you very much.
Thank you very much.
Cheers.